Hello, my name is Trent Short, and today we're going to be discussing baseball and the math behind it. Especially, or this is going to go over a ton of stuff, especially stuff in the beginning of the semester. So to start off with, we have the measurements of the field. As you can see, baseball on the field is very mathematical. So from the pitcher's mound to home, it is approximately 60 feet 6 inches, and it is like that for the high school age and all the way up to the pros. But at some of the lower ages, you get about 55 feet around there. So the baselines are exactly 90 feet apart all the way around, and as you can see right here above or right near second base, it is about 90 degrees angle from the foul line to the baseline. And as you can see to the right more, here's some of the more in-depth measurements. But those are just some of the main ones that I wanted to go over. And every outfield is different. A lot of parks have different designs, so some fields are bigger than others in certain parts of the park. But yep. Next is the statistics and how you go about finding out what specific statistics you want to know. So to start off with, I'll go with hitting. There's tons of statistics in baseball that people overlook, but these are the main ones that a lot of hitters care about and a lot of reporters and everything care about. Especially batting average being the most important. So the way you calculate your batting average is you do your total number of hits throughout the whole season and divide that by the number of the at-bats you have on the season, and you'll find out your batting average. Next is on base percentage, and that's obviously any way you get on base, whether it be a hit, a walk, a hit by pitch, anything that gets you on base will go towards the stat. So the way you find that out is you take your hits, walks, and hits by pitch all added together, and then you divide that by the number of at-bats you have plus the number of walks, hit by pitches, and sacrifice flies. Next is slugging percentage, which is something that a lot of hitters care about also, and that goes towards your singles, doubles, triples, and home runs. You have to get a hit for your slugging percentage to go up. So these are all genuinely super high for really good hitters especially. And the way you calculate that is your total number of bases that you've touched by hit, and you divide that by the number of at-bats you have. Next is the pitching side of things. There's not too many statistics that a lot of people care about a lot, but these are, I would say, the main two, especially ERA, earned run average. And the way you calculate that is you take your earned runs, multiply that by 9, because that's the number of innings that you usually play in a game. The only way that would change is at most of the time, like the high school level, even here in the KCAC, we sometimes play 7-inning games. So it would kind of change your ERA just a little bit. But we're going to go with 9 for here, because that's what the usual amount of innings is played in a game. So your earned runs multiplied by 9, and then divide that by the number of innings you've pitched. Next is the winning percentage. Obviously, everyone wants to win, and you want to find out what your winning percentage is. So you take the amount of games you've won divided by pretty much your total number of games you pitched. So the games that you've won and lost. Next is something that I was really looking forward to do when I came up with this idea to present on. This is the velocity to the plate, and this is how you're going to go about it. So step one, you measure the distance from the pitcher's mound to home plate. Like I said, high school to pros, it's 60 feet 6 inches. So then you measure the time that it takes from the pitcher to throw the ball. Once it releases his hand and then goes into the catcher's glove, then you stop the time. At the major league level, 0.45 is pretty normal. So we're going to go ahead and go with 0.45. And then this is the formula you have. It's S equals D over T, or speed equals distance over time. So in this circumstance, we know both the distance and the time. The distance being 60.5, 60 feet 6 inches, and then 0.45 seconds. And then once you divide those two, you will get 134 feet per second. Then you'll take that number and multiply that by the speed of the ball in feet per second, so by 0.682, and this converts everything in miles an hour. So on average, you're getting about 92 miles an hour, especially at the major league level, sometimes even higher. Over there, I have a table to the right. Those aren't the exact measurements. I just plugged those in and then rounded them up as close as possible to the number, because 80, 85, 90, 95, and 100 are all, it kind of goes in increments of 5 as far as like what people want to see on miles an hour. I'm talking about coaches and players and stuff like that here. So at a time of 0.52, you're going to have about 80 miles an hour. At a time of 0.49, you're going to have about 85. 0.46, you're going to have about 90 miles an hour. 0.44, 95, and 0.41, what is really good, and that is 100 miles an hour. Next is exit velocity, and over here to the left is part of the formula for figuring out exit velocity, and the V-pitch is the velocity of the ball thrown from the pitcher. Next is the V-bat, which is the speed of his swing, and next is the V-ball exit, so the ball jumping off the bat, which is really what we're testing here, and then BESR is the ball-bat collision. Here is the correct formula for testing exit velocity. So, for example, say we have a ball-bat collision recorded at 0.71 miles an hour, and the bat and pitch speeds are 79 miles an hour at the bat speed and 82 miles an hour at the pitch speed. What will the exit velocity be? And at that point, it's just making sure you plug in the right information in the right spot to get the right answer. So to the right, make sure you have the correct bat and pitch speed in the same spot and the ball-bat collision of the BESR, and you'll get approximately something really good, 112.81 miles an hour exit velocity. That's I'd say pretty normal, especially at the major league level, and I'd say even at the collegiate level sometimes people hit it that hard too. And I believe, yes, this is my presentation, and thank you for watching.